All right, today we will be working on adding and subtracting rational expressions. So, when we're adding and subtracting, it's just like with adding fractions or subtracting fractions. You get a common denominator first, okay? And then you need to add the numerators, which will be new if you had to change the denominator. Keep the denominator and simplify. Exact same thing with subtracting. So you'd subtract the numerators and keep the denominator and simplify. Okay, so let's look at some with common denominators, and then I'll show you some without. So if I'm going to add 4 over x plus 3 and 2 over x plus 3, truly I simply do add my, look, I notice x plus 3, they're the same denominator. So I'm going to add my numerators. 4 plus 2 is 6. Keep my denominator, x plus 3, that stays the same. There's nothing here I can reduce because there's no common factors. X plus 3 has that plus in it, it's not 3x. So 6 over x plus 3, that's my final answer. Okay. If I had this problem, subtract 3x plus 5 over 3x squared plus 2x minus 8 from 4x plus 7 over 3x squared plus 2x minus 8. Again, we feel very fortunate because we have this common denominator here already. The order is important, so I'm going to do 4x plus 7 over 3x squared plus 2x minus 8, okay, minus 3x plus 5 over 3x squared plus 2x minus 8. Okay, so again, I'm going to subtract my numerators. So 4x minus 3x is just x. 7 minus 5 is plus 2. So x plus 2 over the same denominator, 3x squared plus 2x minus 8. Okay, and then what I'm going to look for is if we have any common factors. So I'll try to factor the denominator. Okay, and it looks if I play around with the denominator a little bit, like if I try 3 and 1 to get 3 and 4 and 2 to get 8, I multiply here, 3 times 2 is 6, 1 times 4 is 4. It's going to work if the 6 itself, if that's the negative, so, sorry, if the 4 is the negative because we want it to be a positive 2x. So I think my factors on the bottom is 3x minus 4 times x plus 2. If I guess and check, that would work. And the numerator is x plus 2. So you're going to notice these have a common factor that can be canceled out. So x plus 2, x plus 2. I'm going to have my final answer is 1 over 3x minus 4. Okay, so I had to reduce at the end using my simplifying skills that I have from before. But other than that, I just had to subtract, keep the denominator, and move from there. Okay, this is where it gets tougher because we've got this not common denominator here, uncommon denominator. I've got a 4x and an 8. So I want to just think or refresh you on normal fractions. If it was just like 2/5 plus 3/6, remember that we'd have to look for this common denominator, and I'd pick a denominator of 30 here. But when you're trying to figure out 2/5 is how many 30ths, I want you to remember that what you're doing is you're saying 5 goes into 30 how many times? It's times 6. So we're multiplying the numerator by 6 to get 12. Okay, that's really important. If I'm going to make 30, 3/6 into something 30ths, we say how many times does 6 go into 30? It's times 5. So I'll multiply 3 by 5, I get 15 30ths. And then I'd have 12 30ths and 15 30ths, and I'd add 27 30ths, reduce 9 tenths. Okay, same strategy here, but we're going to have some variables in there. But I still need to look for a common denominator that 4x and 8 both go into. So 4 and 8 both go into 8, so I'd pick that, and x, and that has nothing, so no variable. So we're going to pick a common denominator of 8x. So I want to know 3 over 4x equals what over 8x? So I'm going to use the same strategy here. I say, what do I multiply 4x by to get 8x? It's multiplied by 2. So I need to multiply my numerator by 2, and I get 6. Okay? If I do 1/8, and I think, what do I have to multiply that by to get 8x? 8 times x is 8x. So 1 times x is just x. So now I'm adding 6 over 8x plus x over 8x. Okay, same thing. I'm going to add my numerators, keep my denominator. I get 6 plus x all over 8x. I look for anything I can reduce, but there are no common factors, so I'm done. All right, let's continue on and do just another example like this. All right, so we're going to add 7 over x plus 4 and 3 over x minus 5. All right, so I'm looking for a common denominator here. Okay, it's not quite as simple as the last time, but I know x plus 4 is a factor for my first fraction and x minus 5 is a factor for my second fraction. So I probably want x plus 4 times x minus 5 to be my new common denominator. So I'm going to say 7 over x plus 4 equals what over x plus 4 times x minus 5? Well, it looks like I had to multiply by the quantity x minus 5 on the bottom, so I need to do that on the numerator too. So I'm going to have 7x minus 35 on my new numerator. I'm going to do the same sort of strategy. 3 over x minus 5 equals what over x plus 4 times x minus 5? This is why factored form comes in so much more handy sometimes. So x minus 5, that's going to have to be multiplied by x plus 4. So multiply the numerator by x plus 4 again. That's going to be 3x plus 12. Okay, so now I'm adding these. I'm adding 7x minus 35 over x plus 4 times x minus 5 plus 3x plus 12 over x plus 4 times x minus 5. So I'm going to add my numerators. 7x and 3x is 10x. Minus 35 and a plus 12 is a minus 23. And that's all over x plus 4, the quantity, times x minus 5. I could write x squared minus x minus 20, but right now I'm going to say leave it in factored form. 10x minus 23, there's no GCF or nothing I can factor out there, so I am done. Okay, so these problems, if you find that common denominator, it's a lot like solving normal fraction problems, but it can be a little tricky. All right, let's try one word problem. So the distance between Seattle, Washington and Miami, Florida is about 5,415 miles. Okay, so distance equals 5,415. The ground speed for jet traffic from Seattle to Miami can be about 14% faster than the ground speed from Miami to Seattle. So we're going to call Miami to Seattle. We'll just call that. It says use R for the jet's ground speed. Its rate is going to be called R. For Seattle to Miami, its rate is 14% faster. So 14% faster would be 114% of, okay, so if I'm going 14% faster, I'm going the whole 100% plus 14% more. So I'm going to call their rate 1.14 R. Okay, and I want to write an expression for the total round trip air time. So I need to remember that distance equals rate times time. And if I'm trying to solve for time, I know then that time must equal distance divided by rate. Okay, so for total round trip time, I'm going to be doing the Miami to Seattle time plus the Seattle to Miami time. So Miami to Seattle is just going to be distance divided by rate. And I know my distance, so let me plug that in a minute. So distance is going to be 5,415 divided by R, plus my rate from Seattle to Miami was 1.14 R. My distance is still the same, so 5,415 divided by 1.14 R, okay, equals whatever I'm trying to find out, my expression for my total round trip air time. All right, so you need to get a common denominator again. R and 1.14 R. You probably would pick 1.14 R, but I don't like having a decimal inside my fraction because that's not like mathematically normal. So I would probably actually try to get these both to a common denominator of R. That'd be my personal preference this time in this situation. So 5,415 over R, that can stay the same, but then 5,415 over 1.14 R, if I want to change that to something of just R, this time I'm dividing by 1.14 to get to that denominator I want. In 5,415 divided by 1.14 is 4,750. Okay, so now I have 5,415 over R plus 4,750 over R, and now I can just add my numerators and keep my denominators. I get 10,165 over R. That's going to be my expression for my round trip time, T time. All right, so we'll practice this more in class. Hopefully this gives you a little feel for how it's working.